Hi, my name is Greg Cantor, and I'd like to talk to you today about NuCrpyt. We're a small company committed to commercializing technologies that are at the interface of electronics, photonics, and quantum effects. We were founded in 2003 by Prem Kumar, who at the time was the AT&T information professor at Northwestern University. He since left to become a DARPA program manager and has returned to Northwestern as a practicing researcher. I'm the CEO of the company. I've been with it in every project that it's had. I've been the technical leader. We have about 6 people on staff, physicists and electrical engineers, most of which have been with the company for over 10 years. Our main product is a suite of equipment that allows you to distribute entangled photons over long distances, over fiber, between two distributed parties. That's parties in different locations. There is no such equipment that's available by any other manufacturer, and entangled photons are really the fundamental unit of information in quantum communications. Like ones and zeros are the fundamental unit of information in digital communications. So having this kind of a suite of equipment that allows researchers and developers to just straight out of the box do meaningful experiments can be very useful. And our equipment can be used independently, so any of our systems or subsystems or boxes can be used independently, or you can connect them all together to do this kind of grand experiment. We have the software, single photon detectors, the source of entangled photons, and all the communication and electronics you need to coordinate all these different measurements that you have to make at different locations. We also do research and development. We have a number of SBIR type research. Right now we're looking into very low loss, high speed quantum switches that allow you to manipulate quantum signals. That could be useful, for instance, in multiplexing quantum signals, getting them to go faster, or for things like in a larger teleportation experiment. In addition to doing research, we also, and providing lab equipment, we're also trying to move equipment from the lab into the real world. On the bottom left there, you see a demonstration that we did in a moving airplane, an airplane to ground, high-speed encrypted system. So this type of encryption, different from quantum key distribution, allows you to directly send data and use quantum noise to try and make the encryption system stronger. It's much more robust than QKD and allows you to do things like this experiment, a moving plane and a very difficult connection that's has a lot of atmospheric fluctuations and other issues. It can go over thousands of kilometers of fiber, and so it fills a different niche than QKD. So what's the value to financial institutions? Well, the entry point is likely to be security right now, quantum key distribution, quantum noise aided encryption. You see a depiction of that on the right, ones and zeros with, you can see a very clear difference between them in a decrypted signal, and in an encrypted signal basically it looks like garbage. There are also things called quantum auctions, quantum digital signatures, other ideas people have in the security space. Someday there may be quantum computers that are interconnected through very long distances of fiber as well, but that's very far off in the future, and right now we're more interested in things that are kind of nearer term. The financial industry can help there by helping us to define best use cases and advise and guide demonstrations moving forward. On the bottom there you see an RF noise encrypted link that we also developed. One of the benefits of this noise encryption that you can actually do it in the RF space, making things like Wi-Fi connections. So to recap, we have an extensive history in the field, over 15 years, which is very rare given how young the field is. We currently provide robust equipment that works in realistic situations, and we can custom build things for a variety of quantum photonic applications. We're interested in consulting on projects that can bring together multiple parties to show realistic demonstrations, and we can also serve as a third-party technology advisor to evaluate different applications and implementations. And with that, I'd like to thank our funding agencies that are shown at the bottom and the viewer for their attention. Thank you.